Then boys and girls, most of the time we are going to do repeated readings in experiments. So for repeated reading, how you're going to note down the uncertainties. So for a set of n repeated measurements, normally the best value will be the average values. So how we are going to note down the measurements? So we are going to have the average value plus minus uncertainties. So we have the x bar plus minus delta x. So the formula to calculate the average value will be, we were going to total up all the repeated reading we taken, divide by the numbers of reading or numbers of measurements. For the uncertainties, we are going to calculate by using this equation, whereby we are going to calculate the average value of the difference between the measure value and the average value. Okay, let's say we have the repeated reading for a measurement which is given as A, B, C, D, E and F. So how I'm going to calculate the average value? So the average value will be A plus B plus C plus D plus E plus F divided by 6. Why divide by 6? Because we have 6 measurements. Then the uncertainty will be, we are going to take the average value we calculate minus with the measure value for each reading, then we are going to obtain the average for the difference. So that one we'll consider as our uncertainties. So the result should be written as average value plus minus uncertainties. So let's make a practice on this one. So let's see, I have a table whereby I record 7 repeated readings to measure the length of a scientific calculator. You will notice that the raw data, the decimal point, is very consistent with the uncertainties of the measuring instruments. For example, the uncertainty is 2 decimal place, so all the reading will be recorded up to 2 decimal place. So the average value will be, I'm going to total up all these repeated reading, divide by 7, so I get 15.46 centimeter. So since go for average value, it should have the same decimal place as the raw data. The raw data means the data that we measured. Then I'm going to find the difference between the average value with each of the measurements. So the difference between the average value with the first measurements will be 0.04. Difference between average with the second measurements will be 0.09. The difference between average value with the third measurements is 0.16. With the fourth measurements is 0.02. With the fifth measurements is the fifth measurements is 0.03. The difference between average value with the sixth measurements is 0.01. And the difference between the average value with the last measurements is 0.09. Then I'm going to total up all these difference value and then divide by 7. So I'll get the uncertainties. So the uncertainties I calculate or shown by the calculator is 0.062857 centimeter. Anyhow, there is a rules to note down the uncertainties. Our uncertainties must always quote to one significant figure. So for this case, the uncertainty for the length of the scientific calculator will be 0.06 centimeter. So we are going to note down the length of the scientific calculator, whereby it will be 15.46 plus minus 0.06 millimeter. Then class, bear in mind, the reading should be quoted to the same decimal place as the uncertainties. And uncertainties must always quoted to one significant figure. So the percentage of uncertainty can be calculated by taking the uncertainty 0.06 divided by the average value 15.46 multiplied 100%. So we have 0.39%. So maybe we are wondering, what if all the repeated reading we work out have the same value? Then in this case, we would look at the limit of reading of the measuring instruments, we are going to use the sensitivity or the smallest division of the measuring instrument as the maximum possible uncertainties in our result. So again, I remind you, you should always record your measurements consistently in the correct decimal places. So the numbers of decimal places for measure data, including the average, must always follow the sensitivity or the uncertainty of the measuring instrument used, and consistent number of decimal places for all the reading taken. Then calculated data might round off to consistently 2 or 3 decimal places.